confinement method. Let us understand inertial confinement method and magnetic confinement method thoda sa. Let us understand, we have used two terms. Nuclear fusion we are achieving in two different ways. One is inertial confinement, other is magnetic confinement. अब देखो, basically what you want is कि यार this is your, let's say, capsule within which you have what? You have some D and T kept. This is your capsule where you have some D and T kept. What you want? It should be supplied a lot of energy. It will go to millions of degrees Celsius of temperature. तभी fusion हो पाएगा. It should go to millions of degrees Celsius, and at that time, it should not move away from each other. Confinement. देखो, magnetic confinement method, inertial confinement method. We want to keep them confined. We want to keep them close. अब ये नाम आपको थोड़ा समझ में आ रहा होगा. Inertial confinement, magnetic confinement. है ना? Here in this method, which is being used by National Ignition Facility at US. This method, which is being used by National Ignition Facility at US, they use a device called holram. Prelims के लिए ये, अब prelims में they'll not ask you how holram functions, but they'll say this term was in news. What is it associated with? They use a device known as holram. Now, what is this holram? It is a 1 centimeter. So you will see it's a 1 centimeter cylinder. It's a 1 centimeter cylinder. जिसके अंदर what do we have? We have 2 millimeter wide capsule in which what is kept? DNT. So basically it's a 1 centimeter cylinder. अब ये 1 centimeter नहीं है, ये मैंने 20 centimeter का बना दिया है. 1 centimeter is very small, right? Our scale, normal scale जो हमारे pencil box पे आता है, that is 15 centimeter. By that you can understand how small a 1 centimeter cylinder will be. And within 1 centimeter cylinder, they have 2 mm का capsule where D and T have been kept. And to this they provide laser से energy. When they provide laser से energy, the inner part of this capsule produces X-rays. Those X-rays go and heat our D and T. And here, when the temperature increases, a kind of explosion takes place, but a kind of implosion also takes place, which keeps everything confined. And this leads to fusion condition occurring. This is inertial confinement method. Inertial confinement method, what is the device that we used? Holram. And for the first time, we have been able to achieve what? We have been able to achieve a break-even. But this break-even is a fake break-even. Do you understand why? Because we are saying कि इस capsule को हमने x unit of energy produce किया, and यहाँ पे what were we able to produce? 2x unit of energy, and thus we have achieved break-even. But in reality, to generate this laser, we had produced 100x. We had supplied 100x unit of energy. ये laser produce करने के लिए 100x unit. So and that is why we are still far away from developing a nuclear fusion. यहाँ पे हमें gain of 200x 300x चाहिए होगा for this to be successful. Plus, this has been done at a very small scale in lab. Doing it at nuclear power plant level would be a challenge, would be an issue. दूसरा method क्या है? Magnetic confinement method, which is being done at, और जिसका सबसे important experiment is International Thermonuclear Experiment Reactor. UPSC ने last 15-20 years में 2 बार ये पूछा है. एक बार 2016 preliminary examination में, if ITER experiment is successful, what will be the advantage for India? आप PYQ देखोगे उसमें है. एक बार 2000s में कभी. 2 बार ITER के बारे में सवाल पूछा है. वहां पे ब्रेक इवन. लेट्स कम टू इंटरनेशनल थर्मोन्यूक्लियर एक्सपेरिमेंट रिएक्टर. अब इस इंटरनेशनल थर्मोन्यूक्लियर एक्सपेरिमेंट रिएक्टर में ना, वी यूज अ डिवाइस कॉल्ड टोकामैक. टोकामैक इज लाइक, अब ये बहुत कॉम्प्लेक्स सा डिवाइस आपको दिख रहा है. इट इज लाइक पोलो होल्स देखे? नहीं, होल्स नहीं, पूरा पोलो या डोनट शेप डिवाइस है. डोनट शेप डिवाइस, ये ना आधा ऊपर से खुला हुआ दिखाया जा रहा है. इन दैट डोनट शेप डिवाइस, विद द हेल्प ऑफ मैग्नेटिक फील्ड, इलेक्ट्रिक फील्ड, दे एक्सेलरेट atoms of hydrogen. They get accelerated, they move very fast. By magnetic field, they are ensuring that they don't touch the wall, and they keep on getting accelerated at that very high acceleration, at that very high speed. They achieve a very high temperature, and then they fuse at that very high temperature. So this device is tokamak device. This device is tokamak device. Holram used in inertial confinement method, tokamak used in magnetic confinement method. Why is it called magnetic confinement method? Because you are using magnetic field. Please understand, plasma is charged. Magnetic field will be able to direct it. Plasma जो charged particle है, will they have their own magnetic field? Will this magnetic field will be able to repel it, direct it in the right direction? So it will keep on accelerating it. Speed will increase. Eventually, what would happen? Very high speed, and that is very high temperature would be achieved, and there fusion would occur. This is what? Magnetic confinement method. Did we understand? So one big experiment that is being done with international collaboration, where India is also participating, is ITER. एग्जाम में ये कई बार पूछा है, इंटरनेशनल थर्मोन्यूक्लियर एक्सपेरिमेंट रिएक्टर. International thermonuclear experiment reactor. What is being done here? Countries have come together to make a thermonuclear experiment reactor or a large tokamak. देखो, thermonuclear experiment reactor, thermonuclear मतलब fusion. Thermonuclear reaction is fusion reaction. Which kind of nuclear reaction is known as thermonuclear reaction? Fusion. We understand the reason for it? Okay. So ITER is an international collaboration. It is under construction at a site in France and is scheduled to be built by 2025. Aim क्या है? Aim है एक fusion reactor बनाना. 35 countries are collaborating to build world's largest tokamak, a magnetic fusion device that has been designed to prove the feasibility of fusion. Primary objective क्या है? Producing a burning plasma. Now burning plasma का मतलब क्या होता है? Burning plasma, anything when we say it's burning, we say that the energy that it is producing उससे और burning हो रही है. Break even है. Like we'll not call anything burning if we use a matchstick. उससे हमने किसी को जला दिया, फिर वो बुझ गया. Unless you supply outside energy, it is burning only because of outside energy, then we don't call it burning. Burning will be anything जो खुद से इतना energy produce कर रहा है कि it can continue keeping the temperature very high. So what we want to achieve is burning plasma, or basically break even in fusion reaction in the magnetic confinement method. Now what will ITER do? This देखो prelims में they have already asked ITER से क्या करना है? Fusion reaction करना है. Now they may ask you other things about the International Thermonuclear Experiment Reactor project. और 2025 में it is supposed to be completed. इसका construction is supposed to be completed. 2025 is a important year. और अभी मैंने आपको बोला चाइना का जो आज वाला न्यूज था, that was also about tokamak device only. They are developing their own fusion reactor. That was about that. I'll make you write 1 or 2 lines about that also. Give me some time. But ITER experiment के अंदर what do we want to achieve? First we want to achieve is burning plasma. Basically break even हो. आप जितना एनर्जी उसे सप्लाई कर रहे हो उससे ज्यादा एनर्जी इट शुड बी एबल टू प्रोड्यूस, एंड देन यूजिंग दैट एनर्जी वी कैन कंटिन्यू डूइंग फ्यूजन. दूसरा, जनरेट 500 मेगावाट ऑफ फ्यूजन पावर इन प्लाज्मा. दैट इज eventually a nuclear power plant which has 500 megawatt capacity. Demonstration of integrated operation of various technologies which we are using, demonstrate its application. Test tritium breeding. We should be able to produce tritium, and finally demonstrate the safety characteristic of the fusion device. These are all the objective. Please note, India is also a participant of ITER. A few years back, when Prime Minister Modi had attended a meeting associated with ITER, he had said this is an important example of Vasudhaiva Kutumbakam. That is, the whole world is a family, because here the whole world, 35 major countries have come together for the making of this experiment. Are we understanding this? Okay. Now, what is tokamak? Tokamak is this device जो मैंने आपको समझाया था अभी. How does it function? I have already explained you that. If you'll read the note, you'll be able to understand it. India भी अपने लेवल पे some tokamak devices, smaller scale पे tokamak devices पास में बनाने का कोशिश किया है, but we have never achieved break even or anything like that. We are also trying to develop certain things at our own. Okay, so this was about everything about nuclear fusion reaction. I hope we have clarity on it. Nuclear fusion we are not using for energy production right now, because all these devices are in the experimental condition. 2 लाइन और लिख लीजिए. I'll give you more updates on it because it was in the news today only and मैंने notes आपको last week ही दे दिए थे. Just write 2 lines. The experimental advanced superconducting tokamak. इस updates में लिख लो यहाँ पे. Updates करके आज न्यूज में था ये. ईस्ट और ईस्ट का फुल फॉर्म लिख लो. द एक्सपेरिमेंटल एडवांस्ड सुपरकंडक्टिंग टोकामैक. एक्सपेरिमेंटल एडवांस्ड सुपरकंडक्टिंग टोकामैक. एक्सपेरिमेंटल एडवांस्ड सुपरकंडक्टिंग टोकामैक फ्यूजन एनर्जी रिएक्टर. ईस्ट फ्यूजन एनर्जी रिएक्टर. ईस्ट है ना. ईस्ट का फुल फॉर्म तो लिख लिया हमने. Was everyone able to write it? Experimental Advanced Superconducting Tokamak. Basically ये tokamak device ही बना रहे हैं. Experimental Advanced Superconducting Tokamak Fusion Reactor, Fusion Energy Reactor by China. By China achieved 100 million degrees. Achieved 100 million degrees for 1000 seconds. Achieved 100 million degrees का temperature for how many seconds? For 1000 seconds. ये भी they are also trying to develop fusion reactor and in that they were able to do this. अब काम कैसे करता है वो सब हमने समझ लिया है ना. यही ना इसको they are calling it artificial sun. Sun में fusion is occurring. What are they calling artificial sun? This project, this device, because they are making temperature go up to millions of degrees Celsius so that what can happen? The same kind of fusion energy production can happen that is happening in the sun. तो इसी डिवाइस को इसी प्रोजेक्ट को बोल रहे हैं कि हम आर्टिफिशियल सन बना रहे हैं. इट्स आल्सो डब्ड एज आर्टिफिशियल सन. ठीक है. अभी इतना अपडेट रखो है ना, सो दैट यू नो कि देयर इज दिस करंट अफेयर्स अपडेट आल्सो इन फ्यूचर. आई विल सी इफ इट्स मोर रिलेवेंट. आज मैंने 2-3 घंटे पहले ही न्यूज में देखा है. टुमारो इट विल बी इन द न्यूज़पेपर्स आल्सो, है ना. तो इफ देयर विल बी some more thing needed, otherwise we understand what tokamak is, we understand how it will function, we understand artificial sun. इस डिवाइस को हम आर्टिफिशियल सन बोल रहे हैं एंड चाइना ये कर रहा है. प्रीलिम्स में इस तरह के क्वेश्चंस आएंगे. इफ देयर इज सम मोर कॉन्सेप्चुअल थिंग्स आई विल ऐड इट इन द अपडेट सेक्शन फॉर यू पीपल.